We're looking at Chapter 4, Rational Expressions and Equations. Chapter 4, Section 4.5, Solve Problems that Involve Rational Equations. In this lesson, we will solve rational equations. We'll identify the MPVs. We'll identify any extraneous roots. And we'll identify inadmissible values. Recall that non-permissible values are values for a variable in a rational expression that will make the denominator equal to 0. We cannot have this since it would make our expression undefined. So we always have to keep in mind the non-permissible values. The lowest common denominator. When we're adding and subtracting rational expressions, we have to determine the lowest common denominator. We cannot add rational expressions without the lowest common denominator. As you can see in this rational expression, the denominators are alike, and therefore we just subtract the numerators. Once we factor the numerator, in this case, we have x plus 1, x subtract 1, all over x plus 1. We can simplify even more, leaving us with just x subtract 1. Do not forget, though, the non-permissible values are anything that has been in the denominator that would make the denominator equal to 0, so x cannot equal -1. Another situation for the denominator is that one denominator is a multiple of the other, and so if we factor the denominators, we have 4 inside of x plus 5, and you can see that the lowest common denominator in this case will be 4 times x plus 5. Another situation is that the denominators have no common factors, and when there are no common factors, the lowest common denominator would just be the product of the two factors in the denominator. If the denominators have a common factor, once we factor them, you can see that the lowest common denominator will include that common factor. So we see in this case the lowest common denominator would be 4, common factor of x plus 3 times x subtract 3. Solving rational expressions. What we'll need to do is determine the lowest common denominator of all the terms in the equation, and we'll multiply each term by the lowest common denominator to eliminate the fractions. Once we do this, we may end up with a linear equation or a quadratic equation. In this case, the lowest common denominator will be 10x. We multiply each term by 10x. Since x times 10 will give us 10x, 2x times 5 will give us 10x, and 5 times 2x will give us 10x. We see that 10x can be the lowest common denominator. When we multiply each term by 10x, the lowest common denominator, we can cancel out the common factors. We do this so that we can eliminate the fractions. And so, we see that that's going to be 10 times 3, okay, which is what we multiply x by to get the lowest common denominator. When we cancel out the common factor of x and the common factor of 2, leaving 5, we see that that's what we would have multiplied 2x by to get the common factor of 10x. So we have 5 times 7, which will give us 35. In the last term, we cancel out the common factor of 5. So we have 2x times 1, leaving 2x. And so we ended up with a rational equation that is now linear. So we have 65 equals 2x, and of course x equals 65 over 2. our non-permissible values are x cannot equal 0. Let's look at another equation. In this case, we have x plus 5, 2, and 2x plus 10, which is factorable to be 2 outside x plus 5. We see that the lowest common denominator will be 2 outside x plus 5. Since that is this denominator, we can multiply 2 by x plus 5 to get the lowest common denominator. And we can multiply x plus 5 by 2 to get the lowest common denominator. So we multiply each term by the lowest common denominator. 1/2 times the lowest common denominator. And negative 14 over 2x plus 10 times the lowest common denominator. We're going to eliminate the fractions by canceling common factors. We cancel the common factor of x plus 5, giving us 2 times 2x plus 3. We cancel the common factor of 2, giving us x plus 5 times 1. If we cancel the common factor here, we see we just get negative 14. Using the distributive property, we have 4x plus 6 plus x plus 5 is equal to negative 14. So we have 2 times 2x gives us 4x, 2 times 3 is 6, x plus 5. And that gives us, when we collect the like terms and simplify, we have 5x plus 11. To finish solving this equation, we see we have 5x equals negative 25. X would equal negative 5. So let's look at our non-permissible values. Our non-permissible values will be x cannot equal negative 5. So since our solution is our non-permissible value, we see that this is an extraneous root. Let's look at a word problem. This could possibly will show up on the long answer portion of the public exam. We have Steve can mow the lawn in 4 hours. Mark can mow the same lawn in 5 hours. How long will it take both of them working together? So we have Steve takes 4 hours, Mark takes 5 hours. Together, we do not know, it'll be x. The fraction of the lawn that is mowed in 1 hour would be 1/4. The fraction of the lawn mowed by Mark in 1 hour would be 1/5. And together would be 1 over x. So the equation would be Steve plus Mark will equal what they can do together. And so we have 1/4 plus 1/5 equal 1 over x. So if we continue here, we find that the lowest common denominator will be 20x. And so we multiply each term by the lowest common denominator. When we multiply 20x by 1/4, we can cancel the common factor of 4, be left with 5x times 1, giving us 5x. In the next term, we can cancel the common factor of 5, leaving 4x times 1, which is 4x. And in the last term, we have canceling the common factor of x, we are left with 20 times 1, which is 20. A linear equation, and we have 9x equals 20, so x equals 20 over 9. Therefore, together, to mow the lawn will be 2/2 of an hour, 2/9 hours. We see that our non-permissible value, our NPV, is x cannot equal 0. We keep this in mind when we get the solution. If the solution is the same as our non-permissible value, then the solution is extraneous, or we have an extraneous root. If they work together, Roy and Rob can paint a house in 4 hours. Roy can paint twice as fast as Rob. Now, this may be a little bit tricky. How long does it take for Roy to paint the house himself? So we're looking for Roy. I'm going to call him X, or label the time that he could paint the house X. Roy paints twice as fast as Rob, so therefore Rob is 2x. For example, if Roy paints the house in 2 hours, if Roy can paint the house in 2 hours, and he's twice as fast as Rob, then Rob will be 4 hours. If Roy paints the house in 5 hours, he's twice as fast as Rob, which would be 10 hours. So therefore we have x and 2x. What is the fraction of the house that they can paint in an hour? That will be Roy will be 1 over x. Rob will be 1 over 2x. And of course together they could do 1/4 of the house in an hour. So our equation would be Roy plus Rob equals what they can do together. We have 1 over x plus 1 over 2x, which equals 1/4. Our lowest common denominator will be 4x. We'll multiply. In solving, we have to multiply each term by the lowest common denominator to eliminate the fractions. We're not changing the denominator into the lowest common denominator. We're not writing the rational expression using the lowest common denominator as we do with adding and subtracting. We're multiplying each term by the lowest common denominator. When we do that, we can cancel the factors. This would leave 4 times 1 is 4. We cancel the common factor of 2x, leaving 2, and 2 times 1 is 2. We can cancel the common factor of 4, leaving x times 1. This will give us x equals 6. So Roy would take 6 hours to paint the house. Our non-permissible value is x cannot equal 0. And since our answer does not equal our non-permissible value, it is not extraneous. You may want to pause the clip now and try this word problem on your own. I'm going to continue with the solution. It takes Rita 9 hours longer than Lori to make a quilt. Together, they can make the quilt in 20 hours. How long will it take Rita to make the quilt on her own? Well, Rita takes 9 hours longer than Lori, so Lori will be x, and Rita will be x plus 9. The fraction of the quilt they can complete in an hour will be 1 x plus 9, 1 over x, and 1 over 20. So our equation is whatever Lori plus Rita can do, that's what they will do together. So we have Lori plus Rita equals 1 over 20. The lowest common denominator will be 20x, x plus 9. So we'll multiply each one of the terms, 1 over x plus 9 multiplied by the lowest common denominator, 1x multiplied by the lowest common denominator, 1 over 20 multiplied by the lowest common denominator. We can cancel the common factors. Here in the first term, we have x plus 9. That leaves us with 20x times 1, which is 20x. In the next term, we have a common factor of x, leaving us 20 times x plus 9 times 1, which is 20 outside of x plus 9. And in the last term, we have a common factor of 20, leaving x times x plus 9 times 1, giving us x times x plus 9. So if you use the distributive property, here now, we have 20x, and use the distributive property right here with 20 times x is 20x, and 20 times 9 is 180. X times x is x squared, and x multiplied by 9 is 9x. We collect all the terms on one side of the equation and make one side equal to 0. And we have a factorable trinomial that is a quadratic. And we factor it to be x subtract 36, x plus 5. We could also use another method of solving for a quadratic. We'll be using the quadratic formula. And it's up to you which method you use, but the quadratic formula could be used here. We usually find it more convenient to factor when there's a factorable quadratic, but a quadratic formula will work. In this case, we have x equals 36 and x equals negative 5. So it would take Lori, it would take Lori 36 hours to make the quilt, or negative 5 hours to make the quilt. Now, since this negative 5 hours does not make sense to the context of the question, we would reject this. So this is an inadmissible value, since it does not make sense to the context of the equation to have negative 5 hours. The answer would be 36. Our non-permissible values are x cannot equal negative 9, and x could not equal 0. Be aware, if we were looking at contextual problems, that there, especially when there's a quadratic, there may be inadmissible values. So in summary, to algebraically solve a rational equation, you must multiply all terms by the LCD to eliminate the fractions. You may encounter problems that will have an equation that will be linear or quadratic, so you have to know the methods of solving for an unknown in a linear equation and in a quadratic equation. And be aware of any extraneous roots, so there are roots that may equal our non-permissible values, or inadmissible values, which are values that do not make sense to the context of the equation, or the situation rather. These must be dismissed as valid solutions, and you must indicate that.